The universe is constantly changing, evolving from a hot, dense beginning into a vast and complex structure. But this process cannot continue forever. There must be a final state, a point where everything settles, where no further change is possible. The idea of the last possible state of the universe challenges everything we believe about motion, time, and existence itself. From the moment of the Big Bang, energy began to spread and organize into matter, stars, and galaxies. Over billions of years, structure formed, complexity increased, and the universe became filled with motion and transformation. But every process consumes usable energy. This leads to a gradual increase in entropy, a measure of disorder. As entropy rises, the universe moves toward a state where energy is evenly distributed. In such a state, no gradients exist to drive motion or change. Without differences in energy, nothing can happen. The universe approaches a condition known as thermal equilibrium. This final state is often described as heat death. In this scenario, stars have burned out, galaxies have faded, and the universe becomes cold and dark beyond imagination. Black holes may dominate for a long time, consuming remaining matter and energy. However, even these massive objects are not eternal and will eventually evaporate. Through Hawking radiation, black holes slowly lose mass. Over immense timescales, they disappear, leaving behind only faint energy scattered across space. After the last black hole fades, the universe becomes almost empty. Only low-energy particles and radiation remain, drifting through an ever-expanding void. Some theories suggest that even particles may not last forever. Protons could decay, breaking down matter into simpler forms of energy over extremely long periods. If this happens, the universe will lose all structure completely. No atoms, no molecules, no remnants, only the simplest forms of energy remain. At this stage, interactions become extremely rare. The distances between particles are so vast that they may never encounter each other again. Time continues, but it becomes meaningless. Without events or change, there is no way to measure its passage. The universe exists in a frozen, unchanging state. Quantum fluctuations may still occur, briefly creating particles from energy. However, these events are rare and short-lived, unable to rebuild structure. Some theories suggest that these fluctuations could eventually lead to the birth of a new universe, starting the cycle again, in an entirely new form. Others suggest that nothing follows. The universe remains in this final state forever, without motion, without structure, without change. The last possible state of the universe is not a dramatic ending, but a silent one, a condition where everything has settled into perfect stillness, where nothing happens, and where existence itself becomes an unchanging, endless emptiness.